Okay, we'll start with solutions and acids and bases unit. This has about 5 lessons on it. So the first lesson is, or the first part of this unit is dealing with solutions. And then the second part of it will be dealing with acids and bases. We will have a quiz for solutions and a quiz for acids and bases, and then we will conclude this unit with a unit test that will include both parts, solutions and acids and bases. Let's start with the first lesson, that is dissolving, dissociation and ionization. So when we are talking about dissolving, what is happening is that intermolecular bonds break. Intermolecular bonds will break when a molecular compound is dissolved in water. It is important to emphasize the fact that what we are dealing with is a molecular compound. So when we have, let's say that we have a sugar cube that is placed in water, when we have the cube, sugar cube, when we have the cube, the molecules are connected between each other with those that are called intermolecular bonds. But as soon as we are putting the sugar into water, what is happening is that we are having sugar molecules that are separated between each other. So what is happening is that those sugar molecules are separated between each other in water. So the bond between the intermolecular forces is broken. In a difference with dissolving, dissociation is happening when an ionic compound, ionic compound that is soluble in water, or in any solution, soluble in water, are separated into ions. So what is happening is that we have, let's say, table salt, which is sodium chloride, and when we put it into water, what is happening, what we have there is sodium ion and chloride. Okay. Ionization is very similar to what we have here, but it is when acids are ionized, so they are in water. And what is formed on this case is an H+, and whatever is the part of the acid that is forming that acid. Now let's see some examples here. So in this case, what we have is base, because we have hydroxide part here. So we'll write the dissociation equation of the following ionic compounds. This is actually a base, yeah. So now what do we have is that the dissociation equation, when this is solid, and then that means that we are putting this into an aqueous solution. So what we will have will be Ba2 plus, or a barium ion, and that is in aqueous solution, and the 2OH minus, again in aqueous solution. In this case, it's a solid. And then when we write the dissociation equation, what we will have will be putting this into water. So we'll have an aqueous solution plus and Cl aqueous solution minus. And the last one will be ammonium sulfate. And again, this is in solid solution. So yeah, solid state. And then what we have here is an H4 plus in aqueous solution plus SO4 2 minus in aqueous solution as well. When we have the ionization, when we write the ionization, so always we are dealing with an acid. Those are all the examples of acid. Hydrochloric acid is in gas solution, and what we are doing is we are putting it into water. So this will be an aqueous solution, and chloride in aqueous solution as well. And phosphoric acid will be in aqueous solution. Acids do not stay usually do not stay in a solid state. They are either in gas or aqueous solution. That is 3H plus, aqueous plus, or gas. 4, 3 minus in aqueous solution. And then last one, we will have this in aqueous solution as well. And then we'll have hydrogen. Again in aqueous solution, and NO3 minus in aqueous solution. Okay. Now, how are we? Let's stop a bit here and see one part here that we said that when the ionic compound is soluble in water. What does that mean? For this case, what we will do is we will use the solubility table. So we will refer to your data booklet, and we will see that some substances, that is on page 6, so some substances have a high solubility, and some substances has a low solubility in water. So when we see, let's say, limestone, which is a calcium carbonate, then what we do is we refer to the data booklet on page 6. And this has 3 rows. On the first one, we have ions. On the second one, we have that is soluble, because when it is soluble greater than or equal to 0.1 moles per liter, is considered to be very soluble, and when it is less than, it's considered to be low solubility or not soluble. What does that mean? Means that will form a solid state or a precipitate in the reaction. So now then what we have is group 1 ions, which is everything that we have in group 1, starting with lithium, sodium, potassium, rubidium, cesium, and francium. So all those, plus those ions that are mentioned here are mostly soluble except for whatever is on the third row. So RbClO4, CsClO4, and so on. And for the third column, what do we have is chlorine ion that is mostly soluble. So it's soluble to most of the elements beside lithium, magnesium, calcium, so and so. So in this case, when we have the calcium carbonate, what we will do is we will go to carbonate, which is CO3, and then we will see calcium. So for group 1 ions and for NH4 plus, it is soluble, but for most of them is not soluble. So that means that calcium carbonate will be low solubility. Table salt is sodium chloride. So we'll go to chloride, which is on the 4th column of the ions, and then we will see that it's for most of them except for copper, silver, H2Pb, and Tl. So sodium is on the most. That means that we will have a high solubility. And then we have lead 2 sulfide. So now we will treat sulfide as a sulfate ion. So it will be SO4. And then we'll see that it is soluble to most beside calcium, Sr, Ba, Ag, and lead 2. So then that means that we will have a low solubility. Okay, so we will treat that sulfide, even though that we don't see it. Then we'll treat it as sulfate ion. Now, what does that mean in terms of the okay, it's a low solubility, a high solubility? That means that calcium chloride that will be formed will be a solid state. Calcium carbonate, limestone with calcium carbonate. Calcium carbonate will be a solid state of matter. And for table salt, that means that will be aqueous. And low solubility for lead 2 sulfide will be solid. So will not be dissolved, it will not be broken down. Okay. Now we talked about all those three things that we have to take into the consideration: dissolving, dissociation, and ionization. But how can we make it so that we know which one is what? So let's see now. The flowchart that helps to do this, to distinguish between dissolving, dissociation, and ionization, is this one here. So if we have the question that you will ask is, does the compound split into ions? If no, then it's a molecular compound, then that means that it's a non-electrolyte. It doesn't conduct electricity. And if yes, it is an electrolyte, means that conduct electricity, forms ions. Okay, so now, if no, then what will happen will be dissolving. You are dealing with non-molecular compound. And if yes, then you will ask, is this an ionic? Or is this an acid? Okay, or molecular. Okay, and then if it is an ionic, what do you have in this case is that the intermolecular forces, bonds, are broken. And what do we have in the case of the ionic? We have a dissociation. And when we have acid, we have ionization. In case of dissociation, you will have two ions, a positive and a negative ion. Like in the case of Na plus and Cl minus in aqueous state. And ionization, you always will have a cation, which is A plus, and then something else that is forming the acid. But always you will have this. Okay. Now, when we are breaking the bonds, it needs energy to break the bonds. So it needs, and it makes sense because something that is formed in order to break it needs energy. And how do we call it? As the endothermic reaction or whatever. An example for this is a dissociation of table salt. When bonds are formed, what is happening is the energy is released. And the way, the name that we use for that is the exothermic reaction. So if bonds are formed between ions and water, then we have a release of energy. However, net energy depends more into how much is used and how much is released. Okay, so how much energy is used to break the bonds and how much energy is released to form the bonds. So now what we have is that the energy to break the bond plus energy to form the bond will give us the net energy. You will tell more about this when you go to chemistry 30.